Tell Nadia we're getting started. You know if we can see how many people are watching? Oh yeah, it says 0 viewers. All right.
I can see that.
I guess we're not very popular. I'm just checking to see with Nadia to see if we should be waiting for people to start listening.
Mm-hmm.
Meanwhile, how about I give you? I have a collab edit link for you.
Okay.
I just pasted it into the Hangout if you want to check that out. Did you get it?
Yeah.
Awesome, I see you. Do you want to share that with the Hangout? Like, share your screen
Okay.
so that people can see us as we code.
Share screen. Where do I do this?
If you go to the left of the screen, there's probably your second icon. It's a green.
Oh, okay.
On it. And you can choose which window you share, which is kind of cool.
Oh, so I should put in a separate window.
Whichever one you're using Collab Edit for.
Okay.
Perfect. All right, now everyone can see the code. And if people want, they can directly access the Collab Edit document themselves.
Oh, nice.
All right, great. So I guess I'll do a quick intro. I'm Joseph Schiavone. I just graduated from Harvard with a degree in science, and I'm about to start with Palantir as a forward deployed engineer. That's the story. I guess my interest is mostly systems and AI, but I love a lot of other computer topics as well as physics. How about you? Care to share a little bit about yourself?
I'm Guilherme. I'm Brazilian. I study in Brazil at the Pontifical Catholic University, but now I'm studying at the University of North Carolina, Chapel Hill, as an exchange student.
Fun. I have a few friends who went to UNC and had a great time there.
Nice.
Awesome. So I guess we'll just dive right in. I have 2 questions for you. If it helps, you can ignore the second one. We'll scroll that one down so it doesn't distract you.
Okay.
But it's a pretty straightforward question, the first one I'm going to start us off with. So the basic idea is you have some document, and actually I forgot to put in the text that it contains easily hundreds of millions of rows. And it contains a list of all the domains that people have visited in some amount of time. Google, Amazon, whatever, along with the timestamp for each one. So you can see how often people visit each site and at what times of day and so forth. Lots of interesting applications for the data, but for now we're just going to focus on how to process it. So the question here is how to identify the top 5 most visited domains. given a file of this size and of this schema.
Okay.
Take it away.
So the hundreds of millions of rows makes it harder, but if we remove that, if we go to an ideal world where we can have unlimited memory and unlimited resources, we could go through this list and build a hash table in meanwhile that maps domains to number of visited times. So each time you see a domain in the list, you add one. You increment one to how often it has been visited, and then you gotta sort this hash map. You gotta not sort the hash map, but have a sorted list of domain names, and you're gonna sort by the value of the domain name in the hash map, and then you pick the top 5. And that will work for a small data set, but what we have here is huge.
Right.
So,
well, spot on answer. So why don't you start off by telling me what the complexity would be for a solution like that?
So for a solution like that, we would traverse these rows, so linear time on these rows while building a hash table, and then for sorting, we have slightly fewer domains than we have rows, and sorting is n log n. So it's O of k plus n log n.
Right. And that n log n is going to be
the number of unique domains.
Right. That's going to be pretty expensive, as you pointed out. So let's assume that you have the space to build a hash map like that, but you can't afford the time complexity. Can you think of an improvement?
So we have space. So maybe what we could do is have a very huge array, and then each time we see a domain in the list, we move that domain from position 0 to position 1 in the array, or for position 1 to position 2. And these positions are not are like linked lists with all the domains that have been accessed, for example, 2 times. But that would that's weird.
Every domain that's been accessed n times appears in a list in the nth element of this array?
Yeah.
Interesting. And then how would you find the top 5?
Then we would start from the end of the list of the array, and we would have to dynamically resize the array probably, so we would know what's the size of that in the end. And so we start from the end and go down until we see 5 domains, then we stop. That's pretty weird.
Yeah, no, it is pretty weird, but I guess list of lists. I think you're going to find that the moving is going to be an expensive operation. But fortunately, it's not like a complex data type. It's just a string in this case. But yes. Why don't... Okay, I'm going to give you a choice. You can either continue to think, because there is a more elegant solution, or you can start coding it, and maybe it'll come to you, and it won't be that expensive of a change for you to go from your original proposal with just the hash map to the ideal solution.
Wait, are we doing hash map or this huge list?
Either do the hash map and see if it comes to you to make the change that you need to make it better. Because you're on the right track with the hash map. Or you can continue to brainstorm.
So let's go with the hash map.
Okay.
So So
And you
I'm
can use the
gonna
language of choice. Feel free to change the language only.
Python. No, this is not. We can do this.
You're gonna have to use the pound sign. But yeah, it's not a big deal. Don't worry about that. But I'll take care of that, and
Okay.
you can.
So we have a function, the top 5, and we have this table. And what our table is going to be is a list of tuples. Each tuple is a timestamp and a domain. So for each row in the table, we need to set up this hash map here.
Mhm.
So for each row in the table, we have to look at this hash map at the row 1. That is the name. Let's have like name. And add 1 to that. But we have to take care if the name is the first time we have seen that. So if the name is in the hash, we can do this. Oh, let's get the name here. And if not, initialize with 1.
Great. Keep going. Go ahead. Keep going.
So now we're gonna have a list of hash keys. These are all the keys. And then we're gonna sort this by lambda key equals lambda hash of k. And we're gonna have the top 5, which we can get by -5 to -1, I think. Return this.
Great. Looks good to me, except for the fact that you have borrowed a sorting function that is of dubious efficiency on such a large data set. So let's
Yeah.
let's return to our problem now that you've coded this up and think, how can you leverage the fact that you only need the top 5?
Well, we also have all the values in the hash. So maybe we could get the maximum value in this list of values. And then after that we get the second maximum, the third maximum, so on until we have the 5 top values.
How do you find the maximum?
So we can have hash dot pairs. Is that a thing?
What does that do?
I want something that gives me pairs like Google and 10. A list of this.
It just gives you all of the key value pairs?
Yeah.
Okay. And how does that help you?
So I can call max on hash dot pairs, and the key for the max is pair 1.
Do you know the efficiency of max on a list?
Max is linear.
Okay.
And if we run this 5 times, we're gonna get a top 5 pairs from that.
Interesting. That would work.
Mm-hmm.
But you're still iterating over the big thing 5 times.
Yeah.
And you use more space. by creating a new hash.pairs thing. So again, can we do better? You're making up for, you're after the fact trying to find your top 5. Can you be a little bit more clever before that?
If it was the minimum 5, I could just store the minimum 5, and every time someone gets in and pops out, pushes out someone from the minimum 5, that would be fine. But what happens here is entries can become top 5 in favor of others.
That's true. So if you were just keeping track of the minimum, once something leaves the minimum, it can never rejoin the minimum. That's not true for maximum.
Yeah.
But that's not an insurmountable obstacle. You're on the right track thinking about keeping track of a list of the top 5. In fact, I just gave you the answer, except I used the word list.
So we could have a heap of the top 5 or some other structure.
Okay, how that work?
But we would still need to have oh, okay, so after we have this hash, no, yeah, okay, after we have this, things are not gonna pop in and out arbitrarily because we already have processed everything. So we just need to keep the top 5 that we have seen so far.
And how are you going to keep the top 5 you've seen so far?
I haven't studied much that data structure, but I think a heap would work. It stores the minimum or maximum values.
Sure. Just tell me how you're going to use the heap.
You can insert into a heap. You can find the minimum in a heap efficiently and remove from the heap.
Maximum, if it's a max heap.
Yeah.
Good. This is all true. So when do you insert into the heap?
We insert into the heap if we find someone that's more than the minimum, and we remove the minimum and put the new guy.
Okay. So why don't you code up for me what that would look like?
Heap. I'm just gonna sudo heap now for name in hash.
But here's the thing: if you're just gonna heapify the whole thing after you've built the hash, then this is really no better than running max 5 times. I'm suggesting you change something earlier.
So I have to start with this heap before.
Yeah, I'm thinking, what happens if you keep track of a heap from the beginning?
But then I would also have to keep track of how many times I've seen each domain, so so that when I see the domain one more time and it becomes enough to join the heap, but then I would still need this hash, wouldn't I?
Sorry, what did you say?
I would still need this hash.
Yes, I'm saying you still need the hash. I'm just saying, what if you started using the heap sooner?
Okay.
Go back to the definition of the problem. What are we trying to do?
You have documented list all the domains that have the top 5 most visited domains.
Great. So you've identified that we need to iterate over all of the timestamps, right?
Mm-hmm.
At some point, we're going to make a pass over that list.
Sorry?
At some point, we're going to need to make a pass through that whole list.
Mm-hmm.
Right? And we're going to need to build up a count of how many times each hash shows up.
Mm-hmm.
But what if, while we were doing that, we kept track of the top 5?
So, okay.
Having a second step afterwards where we calculate the top 5.
So, after we have inserted, we have incremented the particular entry in the hash map, we
Right.
can see if this entry is more than the heap.min, and we start this heap before.
Okay, I like it. Keep going.
And if so, we can heap.insert or heap.remove min. Is that a thing? I'm gonna assume it can be heap.insert. Okay, then after this, after we reiterate to the table, we're gonna have this heap with only 5 entries that are the top 5, and return those.
Yep. You just need to return everything in the heap.
Hmm?
I'm saying yes, you just need to return the contents of the heap.
Like this.
Sure. Yeah, that's fine. So why don't you tell me, why don't you take a minute to look this over and make sure it makes sense to you, and you think it's correct.
Okay, for the first time we start, there's not going to be a minimum. We actually need to initialize this heap with 5 blank entries so that it works. It would happen here. Something 0 5 times. You know this.
Yep.
Also, the key for the heap is second
Good.
element in the tuple.
Mm-hmm. Yeah, that's fine pseudocode. That'll work.
Mm-hmm. So is there anything else I need to change?
What happens here if there are only 2 elements in the? I know this is. I've changed one of the parameters. But what if you get a 2-row file?
Two-row table, just like this.
Yeah.
So we could, instead of initializing.
What if it's million rows, but they're all Google?
Okay, so instead of initializing it with something, we could have if heap dot size less than 5, and then we insert, but we will not want to remove min. So the size less than 5, we insert, and else remove the minimum and insert still. So we can remove this initialization.
I like that better. Excellent. So what does the runtime for this look like?
Okay, so we're gonna go through each row in the table. The size, this size operation is constant. Insert operation in a heap, I'm not sure, but I'm thinking it cannot be more than like 0.5 because we're only gonna have 5, and I mean that's constants too, right?
Yeah. So it's just a little bit of trivia if you remember the insert time on a heap. You want to take a stab at it?
I would say n. No, I'd say log n.
That's right.
So log of 5, which is small. So
Let's call n the number of files. Sorry, the number of rows in the file, and k what in this case is 5. In case you wanted to generalize.
n rows and k is what?
Top k. You're keeping
Okay.
track of top k.
So
So then
top
what
k.
does your runtime look like?
Okay, so the runtime now is O of n for O of n iterations here.
Mm-hmm.
Size is constant. Insert is O of log k. And remove, I think it's also O of log k because you need to rebalance. And insert. Okay, so n log k.
That's right. And as n gets bigger, that is essentially the same thing as O log n, right? Because the log k term becomes very, very small. Especially when you consider the fact there's a little subtlety in here. That's your worst case. Well, not your worst case. No, that is your worst case time. So that is your worst case time.
Mm-hmm.
Your average is going to be a bit better. Can you think why?
Because they're not gonna modify the heap every time.
Exactly. The bigger the distribution of the number of distinct companies is, the sooner you're going to realize that you're almost never modifying the heap. Or rather, modifying which ones are in the heap.
Yeah. Also, I just realized that I should.
Yeah, you're not updating.
This is not going to be updated. I need to refer to some object that's going to be modified every time I iterate through here. Otherwise,
the hash.
Huh?
I'm suggesting it's better to refer to the hash.
Yeah, we can just insert the name.
Mm-hmm.
And the key is hash the name.
Hash p, yeah. Okay, great. So yeah, this should be very, very close to O log n. I'm saying this should be very, very close to O log n.
Yeah.
Okay, great. Good job.
Thank you.
So let's move on to the next question, which is we'll bring back up a little bit. So this question is one that I got in my algorithms class a few years ago, and it goes like this: you have a rod, for us it was a log, of length n. Assume that it's in some discrete units, not continuous units.
Mm-hmm.
And you're a log cutter, you're a lumberjack, and you want to maximize your profit for selling this log. You can sell the log as it is, or you can cut it into an arbitrary number of pieces, always along the same axis, make it a one-dimensional log, and you want to maximize your profit. And you have a knowledge of what price you can fetch for logs of different size, up to n. So it may be more profitable, as in the first case that I gave you here, to cut your piece of 8 into a piece of 2 and a piece of 6. Because then you get a profit of 22, which is the best you can get.
Okay.
Maybe it's most profitable that you leave the log intact. Maybe you cut it into 8 chunks of 1. It's not clear. Given a list of lengths and their prices, and given the length of the log, I want you to find out what is the best series of cuts you can make.
Okay, so this looks like there are sub-problems to the main problem. We have a big log, and a big rod, and we can sell it as it is, or we can cut it into many different pieces.
Mm-hmm.
So I could cut it in half, and then I have two pieces that I can decide to cut or not. So this is gonna degenerate into sub-problems.
Good.
And I want to find the optimal price. So if I cut it at my rod of length 8 into 1 and 7, or into 2 and 6, I want to find which, or so on. I want to find which cut optimizes it, and that's I can do that by looking at the optimal cost for the rod of size 6. So, okay, we can simplify this by, instead of looking at the two sides, we only look at the right size and decide to sell the left side as it is. And then we know that, for example, for the length 1, we sell it for 1 simply. That's the base case. And this becomes kind of recursive, but we need to keep track of what we have already done before, so that we don't recompute values all over again. And so we're gonna need a table for that.
Okay.
So can I go in coding?
Yeah, you haven't quite finished fleshing out the algorithm, I think. But you can start if you'd like. I think what's missing is what you're optimizing over in order to determine your best cuts.
I'm optimizing for the maximum price I can get for the rights. Okay, so if I have length 8, I have 8 different cuts I can make. I can cut it at 1, cut it at 2, cut it at 3, up until cutting at 8, which means selling the rod at 8 as it is.
Right.
So I'm gonna optimize over that.
There's a little more to it than that, though, right?
Yeah, cutting the left side and selling as it is, and then optimizing the right side.
Right. Okay.
Is that clearer? Clearer?
I think you said it correctly. Well, why don't you go ahead and code it up?
We have the size and we have the prices. And we have our table of optimal. And we're gonna start from the bottom. As also another base case, for the size 0, you get 0.
Okay.
So now we're gonna go for S in range 1 to size plus 1, which means 1, 2, 3 up until size.
Got it.
And then the optimal solution for the size S is gonna be, we're gonna have to define something else here. Okay, so for cut mark and range size, which determines where we're gonna cut, we are gonna have the optimal of the cut mark plus the optimal of the size minus the cut mark. No, we're actually only going to have the price. the good mark, because we already decided to sell the left side. That's gonna be a little simpler.
I'm sorry, what's prices? Oh, sorry, yeah. Okay, so prices is what it's worth. And then what's optimal here? Oh, that's your array.
Yeah, my dynamic programming array. And now for this find optimal, what I'm going to return is I have built this.
What do you haven't done anything with that value?
Yeah.
Oh, I see you're returning. Okay.
So instead of, let's be Pythonic here. Then we want the max over these. And I broke BEP8, 82 characters. So we're gonna find the optimal for this and return the optimal for the size that we have.
Excellent. So unwrapping this from the outside in. So you're iterating over the size, which is to say, essentially, what size log are we working with? And you're building an array of the optimal amount you can sell a log of that size for. And you're building from 1 to your target.
Yeah.
And each one of those looks like where you're maximizing over the value of the left side plus the best you can do on the right side. And that's another sub-problem that you've already seen.
Yes.
Exactly. Very good. I don't see anything wrong with it.
Cool.
So what is the runtime of this solution?
Okay, for size, we're going to have to go from mass to from 1 to size and do find optimal. And find optimal goes from zero to size and looks up tables, which is constant, and finds the max, which is linear in this size. So we have this is going to be size squared.
Yep. It's going to be n squared.
Yep.
And what would it have been like if you hadn't cached your answers?
If I hadn't, I would have size. I would have n subproblems, each with n minus 1 subproblems. And if you multiplied that all the way to 1, that's n factorial, which is very terrible.
I think if you'd used just recurrence, you could have done a little bit better. I think you can get a 2n solution. Sorry, 2 to the n solution. But either way, it's exponential, and that's disagreeable. All right, cool. So you can see the power of memoizing, of caching. Okay, great. Those are the 2 questions that I have for you. I can come up with a third if you'd like, but I think you handled these well. So, did you read the textbook, the How to Crack Coding Interview?
Yeah, I read it a few months ago when I started applying.
Hopefully you were able to identify what I was going for each one. I gave you a scalability question and a recurrence question. DP solution there.
So going back to that scalability question, wouldn't iterating through and building this hash table be a problem if we have millions of domains? Wouldn't we want to distribute that over machines or something like this?
Yes. So this is a question that you can parallelize pretty well because you can look at records individually. The only trick is the count has to be a shared resource, right?
Uh-huh.
At the end of the day, you put together the counts. So you have two options, right? You can count them all individually on different machines, and each one only knows how many Googles it's seen, right? So it has no idea what the global top 5 is, right? It might know locally what the top 5, but not globally. And so when you put it together, then you do have to do an expensive sort
Yeah.
for the top 5, right?
Yeah.
Your other alternative is that you can have a shared count, right? So in parallel, you're looking at records, but you're updating a shared resource of the counts. And that has its drawbacks, because then you have a synchronization issue where each one has to wait on the lock for the counter.
I just had a OS final today.
Yeah, nice. Operating systems was one of the most rewarding classes I've taken here. And I'm sure it's equally demanding there as it is here. So you're probably very happy it's over.
Yeah.
I would, on bad weeks, I spent something like 60 hours. It's ridiculous. But no, yeah, so you'd have a synchronization. You have to either balance with merging the counts at the end, but being really efficient at counting, or having a synchronization that slows you down during the counting, but then you can maintain this heap and you get the answer for free at the end. And only time would tell which one of those is more likely to be efficient. It depends on how often you'll be updating the most often. But logic tells you you're almost after a while you're unlikely to change which are in the top 5 very often, right?
Mm-hmm.
So maybe having a lock on those things is not the end of the world.
Yeah.
Yeah, good point. Good point. So if this was more of a systems architecture design question, that would be a good thing to offer for what, from a computing standpoint, how you should compute this, not just a coding standpoint. You could also turn this into a bit of a product management question by asking, well, what can I do with this data?
Mm-hmm.
Do you have any thoughts? Not just the top 5, but with the whole file.
Well, this is sort of like Alexa, the top ranking, right?
Sure, and what can you do with it?
Uh,
Okay,
you're saying like business-wise?
yeah.
Well, you can find somewhere to target an audience for some advertising.
Yeah. Think in terms of a little more low-level things. You can identify what times of day different websites tend to get the most traffic. You can then identify if different types of which companies essentially compete for certain demographics. You can do something along the lines of finding clusters of similar types of users, right? You can identify different demographics who have similar behavior patterns. And actually, if I gave you one more thing, right? If I gave you the IP, you could even track individual
The
users,
location, yeah.
right?
And location.
Yeah, and location. You can correlate. You can just find location from IP usually.
Yeah, that's what I'm saying.
Exactly. So you can go by location, and you can also identify individual users. You can say certain users like to visit Google and then Amazon 10 minutes later.
Well, kind of, because if a university or a workplace has an IP for all of the computers, then it's not going to work as well.
Sure. Anyway, that's extra credit. It's a different type of interview. But it's the kind of question that I've been getting a lot of in recent months. All right, well, good job. I guess we're done. Do you have any questions for me about technical interviews, what they're like, about jobs or anything? I'm happy to answer any questions.
Um, I don't know. I'm maybe people have questions, but I've done so many interviews.
That's all right. Do you have an an internship lined up for the summer?
Yeah. Um, I'm going with Square Software Engineering.
Oh, nice. I don't think I know any folks there, but I've heard good things. All right, well, it was very nice to meet you. Thanks for doing this. Hopefully our viewers will benefit, few though they may be, according to this counter. And it was nice to meet you.
Nice meeting you. Thank you.
Yeah, have a good night.
Thank you.
Good luck with the internship.
Thank you.